Hello everyone, welcome back to another video. Today we will be looking at how to control a TurtleBot simulation running on Gazebo and controlling the robot using natural language using the ROS-MCP server. So as you can see that I am inside the repository of the demos ROS-MCP server. You can find the link here. You can clone the repository, and once you've cloned the repository, you should have the Thor example with you. And inside the Thor example, we have the workspaces that we'll have to build and use it for the purpose of building simulation, as well as I'll show you the steps on how to control it and set up your ROS-MCP client for you to start controlling your robot. So let's take a look at, let's go inside the folder. So as you can see that I'm inside the folder now. So now I've already built the workspace for me, but now in case for this demonstration, I'll remove this and build it again from fresh start. So let me just do rmrf. And this removes the workspace. This removes the installation, the older installation from there. So after this, now you can actually start installing it from fresh. You just do convert here. Should start building all the packages inside your src folder. Give it a second. So it might take some time for it to complete it. So that's okay. Make sure you give it some time. All right. So as you can see that the package has now been successfully installed and it's ready to use. So the next thing that I need to do is I need to set up an environment variable for which TurtleBot version I need to use. So as you know that there are 3 different kinds of TurtleBots that come usually. So there's 3 different kinds of TurtleBots that usually come. The burger, waffle, and the waffle pie. You can choose any one of them, and after you make the choice based on the model that you have right now, you would have to set an environment variable under the name TurtleBot3 underscore model, all caps, as environment variable with the name of the TurtleBot model that you wish to sort of choose. So for this, I'll be using Burger, but you're free to choose any other model as well. It supports all the other models, right? So let's try to export it and set our environment variable. So TurtleBot3 underscore model, and then let's sort it as Burger. So let me just verify you can do it as well. So you can just echo this total model, and as you can see that I get Burger response, which means that this environment variable has been assigned this value. So after this, let's try to start the main ROS ignition gazebo package, and that will essentially start up a simulation. So for this, I'll be using a simple basic environment, but as you can probably read from the README, it will have sort of other supports for different type of environments as well. Please note that the fact that classical gazebo might not work, and this has been built specifically for ignition gazebo, and you might sort of face some issues with sort of if you were trying to use an older version of the simulation. So make sure that you only use the ignition compatible files and Word files for this. So first thing that you need to do is that you need to first source your terminal with the installation that you've made just now. So if you go on ls, there's an install folder. If you go inside the install folder, you can see the setup.bash. We need to source this and run the commands inside this setup.bash file. So we can just source setup.bash, and this should have all of the compatibility for the workspace done for us. After that, we can go back to the main terminal and we can just do ROS to launch. Now it should already have the workspace for us, which is going to be TurtleBot3 underscore gazebo, and then I'm going to use the ignition underscore TurtleBot.launch.py. So I use this, and this should essentially launch a gazebo simulation, ignition gazebo simulation, and it should probably operate. So it might take some time for it to sort of set up and sort of cache everything in the first time that you do it. I'm probably doing it for the second time, so it's much faster, but just give it a second until you see it. And as you can see that I have the TurtleBot TurtleBot Burger model spawned up right here, and this is the one. You can also teleoperate it, but for this demonstration we'll be using on how can you use your natural language to control this particular robot and sort of move and interact with the environment that it is there right now, right? So how can we do it is we need to use a ROS-MCP server for it. So in case you wish to install the ROS-MCP server, you can follow the steps that I have described in another video. I'll make sure to put a link in the I button as well as in the description box below. So you can use and follow that. Make sure that you have the ROS-MCP server, and after you have the server, you also need a client. So one of the easier ways to do it is that you can use Claude desktop app or Cursor, or both of them sort of something compatible with an MCP client inbuilt. But if you do not wish to install these softwares, or or your system is not compatible with it, you can also use ROS-MCP client, which already has the integrations for the ROS-MCP server. You can connect any of the LLM providers like Gemini, OpenAI, Anthropic, or even the open source ones that comes like GPT, OSS. You need to generate a API key from Grok for you to be able to use those things. But once you have that set up, you can use very easily use it from a terminal as well. I'll be using that right now, but in case you want to install it by yourself, you can follow the tutorial that I have sent it. That you follow the tutorial that I made before, and that should be good to go for you to sort of set both the server and the client. All right, so that's it. I think the next thing that we need to do is that we'll open another terminal because we need to start the ROS bridge as well. So I'll expand this. Now, the fact that the simulation is just running inside Gazebo, and Gazebo and Ignition are communicating through one bridge, but the ROS-MCP server sort of publishes its command inside a WebSocket, port 9090, and then we need to sort of make a bridge that connects ROS to this ROS bridge. So we need to start the ROS bridge as well, and then what it will do is that will connect ROS to the ROS bridge server, and then MCP should be ready to sort of start publishing the publishing commands which the simulation can hopefully read. Okay, so in case you do not have it already, make sure that you install the ROS Bridge server, and then it will have the ROS Bridge client for you. So let's do that. I already have that installed, but in case you do not, make sure you follow this command, and then you should be good to go. So we'll do ROS Bridge server, and then we'll do ROS Bridge WebSocket.xml, and as you can see that it has shown us that WebSocket server has started on port 9090. So that's a good sign that it started. The WebSocket has started successfully. In case if another process is blocking this, it will show you an error, and then you probably have to close that particular report or the operation that's running there, and then you'll have to rerun this launchpad again. All right. So once we have this, we can open another terminal, and I'll create that as well. And my goal here in this terminal would be to start the client and start giving it the commands. So as I told you that I'll be using the terminal-based ROS-MCP client, but you are free to choose other clients such as Cursor or Claude as well. Okay, so let's go back. I have the client repository already here, so I'll just go to I just go there, and as you can see, then this is the client repository that I have cloned. You can also clone it from the link for the following link. Okay, so one thing that it comes with is a UV project or toggle. So you can create a virtual environment from UV, and then basically that will have all of your dependencies. Once you have the dependencies, you can activate the virtual environment. So I already have the virtual environment, and I'll just activate that so that there's no dependency issues. All right, so I have the virtual environment activated. So the next thing that I want to do is start up my base client. I'll do that as well. So I'll do UV run clients. Okay. So this should probably resolve any dependencies that I have. Okay. So as you can see that I get the message that the MCP client is now initialized and connected. So that means I can start giving commands to the robot running here in the simulation. And okay. So now let's try to give it some commands, and let's see how well the commands are being executed on the simulation. And because it's running well on the simulation, you can obviously follow the same steps for the real robot as well. All right. So I would like the robot to first see if it can move in a circular direction, and within a radius of maybe like 1 meter, to check the trajectory of mapping and sort of the command instructions that the MCP gives. Right. So I would just give it a simple prompt like move the robot in a circular trajectory with a radius of 1 meter. All right, so this should start communicating with the client as well. So now let's take a look at the simulation, and let's see if there's any changes. As you can see, the robot has started to move, and I'll look at it from top view. And as you can see that this is sort of like a circular trajectory. It's and it's following it, and it's sort of making a 1 meter radius as well. It's big enough to sort of notice that, yeah. And it's completely happening autonomous. The MCP is giving commands to control this robot, and there's no human intervention that's involved here. So the next thing that I would like to do is to make the robot stop, because I think that it's moving. So I'll just make the robot stop. All right, as you can see, the robot has now stopped moving. It was already moving in a circular direction, which was the commands that I gave it. Okay. Yeah. So the stop command was sent, and if you want to inspect it, you can also inspect it that what the MCP actually did and what are the topics that it saw. So you can also ask it to sort of get more information about the different topics and robot topics that you're dealing with here, right? So we can also ask it about what kind of different topics are available, and what are they, what do they mean, right? So okay, so in case you want to understand more about it, you can just quickly do it using this, and this will give you a holistic view about um, what the robot is, what kind of different topics are available, and that will help you debug and do different things. As you can see, I have gotten response from it. As you can see that I've gotten all the different topics that are available and associated with what exactly are the different, what are they doing, what kind of messages they're expecting, and what are the use of each of these commands as well. So this is nice because now I can inspect my robot and be able to do things with it. I can also ask something similar for if I want to debug something, or maybe, if I'm not sure about what the specific comma for a specific topic is doing. So it would come in handy if you were to use it like that as well, not just for teleoperation. All right. So I think this was it. Thank you so much for watching this video. I hope you like it.